All right, so I'm just going to go through some titration curves with you to try to get you more familiar. All right, so here we're looking at a, zero point 0.1 molar solution of 10 mils of it. Wants to know the pH of the solution. HCl is strong acid, so we know that the concentration of that is the concentration of the H plus ions. And to get the pH, all we need to do is the negative log of the H plus concentration, which in this case is the 0.1. And once we do that, we see that the initial pH is 1. Okay. All right. Now it says how many milliliters of 0.10 NaOH. This is a strong base. So we know that this is just a simple M1V1 would be required to neutralize. So we're going to be using M1V1 equal M2V2. Obviously ran out of room over there. But basically you have 10 mils of the 0.1 molar hydrochloric acid. So you want to know what volume of the 0.1 molar NaOH you're going to need. Didn't mean to put equal sign there. So it's going to be the same thing. It's going to be 10 mils. Okay, so you need 10 mils of the NaOH to neutralize that amount of acid. All right, the pH of the neutralized solution. Well, strong acid, strong base make a neutral salt. And since it's a neutral salt, we know the pH will be 7. The pH of the solution if you added 20 mils of NaOH. Well, for that, you're going to need this little chart down here. So you have 10 of the HCl, and then you added 20 mils of the NaOH. You need to find the moles of H plus and the moles of OH minus. Well, we have the molarity of the solution, and we also have the volume, so we can use those to find the moles. So we know moles over liters is equal to molarity. So here, for the H plus, we're looking at HCl, so we're looking for moles. We have 10 milliliters, okay? So milliliters, you would move 3 places this way to take it into liters. We have 0.010 liters, and that's equal to our concentration of 0.1 molar. So you cross multiply, and that gives you the number of moles. So the number of moles of H plus are 0.001. We're going to set up the same thing, but now we're going to use our numbers for the OH, which is the NaOH. Still looking for moles. Now we have 0.020 liters, and the concentration of the NaOH was 0.1. Cross multiply, and you get 0.002. Since HCl and NaOH would be in a 1-to-1 ratio when they react to make NaCl and H2O, then that means that no converting is needed as far as mole ratios. We can just look at these directly. So we know that we're going to have 0.01 excess of the OH. Okay, now the total volume. Well, we had 20 mils and 10 mils, so our total volume is 30 milliliters, which in liters is 0.03 liters. To get the concentration of our OH minuses, we're going to do the moles over the liters, and that's going to give us our concentration, which is 0.033, and this is OH minus. All right, molarity. All right, now if you do the negative log of that value, that will give you the POH. So when you negative log it, you get 1.48. That's POH. And then 14 minus that will give us the pH. So our pH for this one is, let's see, 12.52. Okay? All right, then on your sheet, you're asked to do this step by step much and graph it to get a titration curve. So you should do each of the steps multiple times, and then you will eventually have pH values to graph the pH versus the volume of base that you added. And you will get a pretty little titration curve that should look like that. The equivalence point should be at 7. So if you have any questions, just Sally me and I'll be glad to answer your questions about this, okay?